Yeah, I think I got a pretty good
It's nice to see
centering.
It does.
Oh, yeah. All right. We're live, so I'll do introductions.
You can get my emails. I'll drink my water.
Well, I want to welcome everybody, all the hardy souls on this cold, but not too bad tonight. At least it's dry. I'm Roger Jackson. I'm board member of the Rocky Mountain Inventors. I think everyone here is familiar with the group, so I'll skip all those introductions and everything and just talk about so we got coming up. I've got scheduled through February, so we have Gene DeGennaro, and he's going to talk about finance and revenue and those sorts of things. So every once in a while we have a presentation on those things. And he's experienced it running large organizations, so probably good to pick up a few things because bringing money is the ultimate goal of your invention eventually. And then after that, Patrick, he'll be the fourth Monday meeting for manufacturing, sourcing, selection. So yeah, very important because you can't really do your marketing or social media until you have your manufacturing in good shape so you can deliver to the demand. So anyway, we'll go ahead and start with our round robin. This is Steve. Let us know what's new.
Oh, what I've invented is a device that loads and unloads pallets off of vehicles. And right now we are beginning our first, as I was telling this gentleman, we started out with the idea that we'd make it out of mild steel, welded up, and it would work. Then we thought, well, gee, that adds a lot of weight to the vehicle. So we came up with the idea, we'll make the prototype out of aluminum. We can weld aluminum. And then we looked around and said, gee, you know, the really best thing to make it out of would be magnesium. So we have custom magnesium extrusions that we're having made for us. And the extruder is going to make a set of 10 sets of extrusions to make the device for us. To make extrusions for us so that we can make the device.
Okay.
And that's pretty much where we are now.
Why would you pick magnesium over aluminum?
Because it's about 1.1 times stronger than aluminum, and it is 40% less weight. So it is 38% less weight than steel.
Okay.
And that's the reason, mostly so that you don't increase the tear weight of the vehicle that you're adding it to.
Right.
Because every bit of tear weight you add to the vehicle reduces the amount of cargo that you can haul.
Right, yeah.
And they have enough trouble now as it is.
Okay.
So it would weigh, if these things mount transversely on the frame. And if you mounted, whatever you mount to the length of the frame is lighter than a flatbed of the same length. So that'll give you an idea of where our thinking is headed. And it has the ability to unload pallets off of a vehicle in under 2 minutes.
Okay, good.
That's the entire vehicle. That's not just one pallet. One pallet can be unloaded in 47 seconds. So it significantly reduces detention time, which is the time spent waiting for loading and unloading. Because you don't need a forklift. You don't need to have somebody come back from lunch. You don't need to worry about a forklift driver strike or that it's broken.
Is this mounted in the bottom of a semi-trailer?
It's mounted on the frame of either a semi-trailer or it's mounted on the frame of a two rail, straight rail truck, which means you can't put it on a pickup because pickup frames are curved.
Okay.
I'm Mike, associated with Waterboxx, flood barriers, kind of a versatile barrier item. And Joe is usually my partner. He's out in Vegas this week, so see him later.
Is he vacationing or business?
No, we're arranging for the ConExpo convention. So he's booking the rooms and finding a place where he can store barriers.
Okay.
Send him out there early and store them up.
Oh,
And
okay.
then bring them out when we're there.
All right. That's that construction exhibition. Okay.
Yeah, once every 3 years, largest in the world.
Wow.
There'll be, what, 400,000 attendees? Something like that.
I don't know if it's that many, but it's certainly, I think last time was 128,000.
Oh, okay.
But all the big boys are there, you know, John Deere, Cat, all those guys are, this is the show.
Yeah.
Anyway, we're already part of that show. We have our exhibit space and everything else. So selected a nice corner, so we have 2 streets. And that way everybody can see us.
Okay. Good. Jane?
I'm James. I'm working on this product here. It's a modification to either like a cell phone case or e-reader, tablet, anything, handheld device. It incorporates a blue light filter and or privacy filter screen that's an easy overlay type deal. And working with Roger on that.
And is that blue light filter for use in like a dark room or a?
So typically it would be used for like nighttime reading. It cuts that any wavelength below this particular filter, any wavelength below 500 nanometers, which the blue light supposedly reduces your melatonin production and creates sleep disturbances.
Right.
So if you're reading at night on your phone, this is a simple fix. to
Keep
cut
them
out-
going to sleep, yes.
Well, it helps you fall asleep.
So,
It keeps-
so it's not good when I'm drinking my coffee.
you could drink coffee.
Stimulants probably not advised. Okay,
Yeah.
Patrick?
My name's Patrick from KLM Products Group. We help inventors once they have a product out there to market it through e-commerce channels, wholesale channels all the way through. We also are associated with Vendors Launchpad to help with the manufacturing process if you need that, and sourcing manufacturing from around the world. So.
Okay, Bruno?
I'm Roberto Rusquena. I'm a patent agent. I've been an electrical engineer. I've been practicing patent law for 15 years now. I'm registered with the USPTO. Most of my applications are coming from Italy. I'm the US correspondent of a few Italian patent law firms. So I do the filing and prosecution in the US of applications that usually be already filed in Europe.
Gary?
Hi, my name is Gary Paulus. I have a couple of fitness products and actually using some 3D printed parts. So I was curious to see what Midwest Prototyping was doing. So.
All right, and Desi?
I have a product that's on the market and I'm making a change and going to try for a patent on that. And another product right behind it.
Okay,
And then patent search process right now.
all right, well, our speaker tonight is Dave, is it Scarano?
Yeah, Dave Scarano.
Scarano, Dave Scarano, from Midwest Proto.
Yep, Midwest Prototyping.
Midwest Prototyping. So he's brought a lot of sample parts here, and we can pass them around and be sure to ask questions during the presentation and find out what you need to know in 3D printing and what's new.
Yeah,
All right,
I
thanks.
can't answer. I can get the answer.
Okay.
If I don't know it, I know people who do.
Again, yeah, Dave Scarano, Midwest Prototyping. Appreciate y'all, coming to listen to me talk a little bit, share with you just a little bit about our organization and kind of some of the technologies that we offer. We offer a pretty wide variety, along with some traditional, traditional manufacturing capabilities. So we're, there we go. All right, so basically a little bit about us. So I'm business manager of we'll call it our mountain region, or Colorado or mountain region to the west, sort of 3D printing hub, so to speak. I was brought on about 7 months ago. I used to work at a company called, was MCAD Technologies, turned into computer-aided technology. So I've been in industry for a long time. I'm originally from the Midwest. So I've been doing this kind of since 2001. So a little initially familiar with the Stratasys FDM technology from back in the day. That's how I kind of got introduced to, and saw my first 3D printer and was staring at it like a TV, which is kind of interesting and fun. But as an organization, we're an AS 9100 certified manufacturer. We're ISO 9001 2015 certified. We're ITAR registered, basically for aerospace, in the atmosphere and out. Really, that's focused more on obviously aerospace, but the benefit to everybody else is that we have a pretty stringent quality management system that we kind of adhere to. As far as all of our other, whether medical products or consumer products, they're all kind of held to the same standard. So we're audited on a regular basis. So we're pretty locked down, so nobody can just stroll in and take a look at what we're 3D printing for our customers and things like that. So it's pretty important. But we were, I think, the first independently owned additive manufacturing or 3D printing service bureau, whatever you want to refer to it as these days, to get these certifications in the United States. Right now we have 7 in-house 3D printing technologies. We'll go through those in more detail later. Each technology has multiple experts as far as like heads of the department, and then they have people under them who kind of oversee. So then that's their mantra is to get as good as they can to technology and understand it as well as they can. We're an early adopter of a lot of technologies like HP. We helped bring that. We're one of the initial service bureaus who had that. Carbon's technology, some of these names, some of you may never have heard of, some of you maybe have a little familiarity with 3D printing and have heard of that sort of thing. We have examples of the technology here. But I'll just move on to our organization as far as where we're at. I mentioned I'm in Westminster, Colorado. The headquarters is in Blue Mountains. That's a part of the building there. You see in the back of that, there's a much larger portion of it where a lot of the 3D printing technology is. We're actually just purchased land, and we're getting ready to build another location. So they're going to be moving and expanding the location to a different, near, basically Blue Mountains, Wisconsin. No one usually knows where that's it. So it's outside of Madison, about 15, 20 minutes. So that's where that's at, Madison, Wisconsin. And they purchased what used to be Protogenic out here, if anybody had ever done some business with them, which was a well-known 3D printing service bureau. And I'm been brought out here to kind of revive that business because a company named Tenier, who decided to buy that company and then purchase 2 injection molding companies and focus all their effort on that, kind of ran it into the ground, which was kind of hard for me to see as someone who had Protogenic as a customer because they had my printers that I had provided them. So we also have a dedicated large urethane casting facility outside of Mount Horeb, another suburban Madison. So we have a large dedicated urethane casting facility.
So the urethane is a molding and not a 3D printing?
Mm-hmm. Yeah, so that's one of the traditional manufacturing options that we use, along with some minimal CNC capabilities. We have tool room lathe and Haas 4-axis mill. Just in case, part of a job that a customer wants, requires that sort of, this sort of work. We usually go to urethane casting if someone's really looking to dial in the properties. Let's say, we have 45 plus different materials that we typically, offer at this point. There's other that are available upon request, but typically we just talk about 45, the most common ones. They handle most applications that are out there across the 7 different technologies. But sometimes, someone wants, You know, we can 3D print a rigid plastic part with a rubber overmold, but someone might want something a little bit more durable that's going to last longer and not just be like a prototype that's going to hold up for a little bit, you know. That's when we maybe go to urethane casting, and also that lends itself to more of a lower volume production sort of, you know, situation as well. You know, thousands. You know, that's really where additive manufacturing or urethane casting is kind of where it's, you know, we're kind of at with that, because that's where our specialization is in prototyping, manufacturing aids or production aids, you know, jigs, fixtures, you know, guards, machines, things like that, or, you know, low volume production. That's kind of the niche and where our focus is at. I'm not gonna read all this. But founded in 2001, the organization was out in, you know, Blue Mountains, Wisconsin. Some of the more relevant things that we have done, obviously, is I've mentioned the carbon technology, brought on the HP multi-jet fusion technology, basically helping these organizations bring their products to market. As you probably heard, 3D printing is kind of evolving as far as a lot of new players, people trying to throw money at it, like GE, HP, companies like that, making their own technology and evolving it further. So we kind of help those organizations. They put their machines at our facility, and we do a lot of beta testing. We have a lot of technology in the background that we're testing and utilizing. Well, I'll just say testing, not necessarily utilizing as in like production for customers, but that we're not even, you know, advertising that we have at this point yet. So I did mention that we're the first ISO certified company in the U.S. So that was kind of a big deal. And then, you know, 2018, mid 2018 is when they basically acquired the organization that was Protogenic and is now you know, part of Midwest Prototyping, which is going to be the Mountain Region Hub. So getting on to the interesting part, the technology that we have. And feel free to ask questions. You don't have to wait for me to finish or.
Those look like carbon machines.
Those are actually SLA Systems. That is a picture in our Westminster facility where I'm located of a bank of our SLAs. We have the big boy with the red one in the corner. That's a pretty large system with a lot of capabilities.
Who made those machines?
A lot of them are 3D systems.
Okay.
Most of the SLA equipment that we have are 3D systems. We are evaluating other technology though, because we're trying to think 5 years ahead. So there's some companies, this company called RPS out of the UK that has some very interesting equipment that we're about to have delivered to us. And you know, we're gonna test that out and see where that's gonna go. 3D systems is, you know, and Stratasys are still two big elephants in the room, but there's a lot of new people coming out with technologies that, you know, might make a little bit more sense. Because innovation, honestly, with both those companies, not that their technology, there's anything wrong with their technologies. SLA, that's a huge part of our business. It just, you know, along with SLS, laser sintering. But if they don't, they're only 3D Systems' method of growth right now has been to acquire organizations and not necessarily innovate. So we're trying to look at more organizations that are innovating, bringing something new to the table instead of being a me too, where, you know, help us be a little more unique.
Do you work with any investment materials?
Oh, investment casting?
Yeah.
Like waxes and stuff?
Yeah.
We do not have anything like wax that will melt away or anything like that.
There are plastics that can be used.
Yeah, it depends. For example, Stratasys, they have some materials. I guess it depends on their process. Some companies will actually go ahead and burn out like an ABS or something to that effect, like that Stratasys has. But some companies don't like it because it'll leave a lot of ash. Right. And they have to do a lot of cleaning up. And so it's nothing really that's meant specifically for that.
Okay.
Just to kind of.
So what does SLA stand for when you talk about these machines?
Well, so SLA, I'll jump to that later. SLA, stereolithography. It was And SLA is just you're going to hear a lot of acronyms, and I'll try to remember to not, stick to those. But stereolithography, really what it is, it's the original, like mid 80s, they came out with it, and it involves basically a resin polymer cured with lasers, and they do it layer upon layer, in a vat, and it creates a physical object, and from there you kind of remove it from the vat and clean it up. And an example of an SLA, they're very well known for their feature detail. So this is not like meant to be, physically tested or anything, but it does highlight the kind of feature detail and precision that you can get out of these type of machines. For example, this very good surface finish, we use some SLA materials as our master patterns for our urethane casting.
Is that a top down or up?
So that's going to be you're basically the laser's hitting the top of the vat, and it's kind of dropping down. And I've actually got a little, when you leave up there, there's kind of like we have a little 3D printing guide that kind of breaks it down simply.
Okay.
And each of the technologies kind of gives you an idea. For example, and we're kind of jumping ahead because we're going to get into this too, but fused deposition modeling, or FDM, Stratasys, they created it in '89. It's like, think hot glue gun, right? So it's just going layer upon layer. And a lot of one of their patents ran out, years ago, and that's when the MakerBots of the world and that level of printer kind of came to fruition. They hold a lot of the patents that allow you to be to reproduce, consistent, tolerances and things like that. But more often than not than the $2,000 level printer, but that's kind of where that's at. But eventually those patents will run out, and but I don't know if anybody's interested. This is an example of the fused deposition modeling. It's something that most people have seen. Most people have seen like SLAs and FDM technology out there, but I'm gonna dive a little deeper into those here a little bit as well. But really, I've already kind of talked about this in various applications: functional prototypes, show models, patterns. SLA, that I've sent you around. That's one of the big technologies for that, materials. End use parts, production parts. You get into more like urethane casting, DLP. If anybody's heard of the carbon technology, they've got some really nice parts for production. And then you have manufacturing aids where you start getting into laser sintering, HP's multi-jet fusion, some CNC machining. I won't spend too much on this, but some people are interested in this because they're like, well, when do I use what technology? What's a good fit? And this is obviously, and I put it in the corner, non-scientific generalization, of when to use these type of technologies. For example, like FDM, like that little part that we're passing around now, meant for high durability, high stability, strong, functional. Obviously, it depends upon the geometry. If you're printing something very thin, not going to be very strong, right? You're going to be able to break it. But in general, that technology and the materials that are available in it, because you can print an Ultem, for example, 9085 that is, FST certified, and you can have I think it was a few years ago, a new Airbus or I think it was an Airbus, I can't remember, but they had 1,000 3D printed parts in it. Nothing critical, but duct work, the little doodad that blows air on you, things like that, because it would, if it caught fire, it would go out within a period of time and let off a certain amount of smoke. So just things like that are some end use, part applications that they're being used for. On the other end of the spectrum, that little castle, for example, resolution and feature detail, right? So this just kind of gives you an idea, and I can share, if anybody's interested, I can share a little PDF of the PowerPoint at the end. That just seems to be for people who are leveraging 3D printing and just like, I don't know what to even ask for or what direction to go with technology. It's kind of a nice little guide that you can use along with something like this.
If you could just email me and then I'll get it out to the whole group.
Okay. Yep, I can do that. So getting into the specific technologies, there's different kinds, like powder bed fusion. So basically it's, you've got a powder bed of material, whether it be like a nylon 12 or, anything like that. And I'm talking polymers because there's also powder bed systems out there that print metals. That always comes up. We focus on plastics right now. We don't print metals. We're waiting to see how the development of those technologies shakes out, because we don't want to invest $1 million in equipment and infrastructure and then try to make the economics of that work. You kind of have to have, going in to do that, you have to have some projects or some people committed to spending money with you to go ahead and make that work as a service group. Just to be honest, not that we don't want to provide it, but we do have partners who do have metal printing. But we're waiting for some, Stratasys, HP, some other companies like that have some higher volume, Desktop Metals of the world, Markforged, have some things in the background that are going on for some a little bit more production level type of, metal 3D printing that's a little bit more affordable as far as the entry level point. So we're waiting for that to flush out a little bit before we jump in ourselves. But getting back to powder bed fusion, is anybody familiar with laser sintering? So basically, I was talking about lasers with, like, you asked about the SLA technology or stereolithography, and you're using lasers with the polymers to create the part. Well, in this case, this company is using lasers with powder, mixed with powder, to go ahead and sinter it and create the physical object. An example, this is a nylon 12 simulated part. As you can feel it, and it's assembled, it's a couple pieces, so don't be alarmed if it starts coming apart on you a little bit. Well, I shouldn't say come apart. I mean, there's pieces of it, so it kind of comes apart that way. But that's basically as is. They went ahead and blew off the, very minimal processing to that, because you can feel it's almost got like a bony texture to it. So, I mean, you can make it very smooth, but that's just an example of one of the parts that would come off of that. They're a little more durable. I'm not that I'm going to read everything off of here, but basically durable nylons and composites. They do have both flexible and rigid options. No translucent materials that we print. Pretty good resolution. It runs the gamut. It's our second largest contributor to our bottom line. SLA, SLS are the two big boys that typically we do a lot of work with, just because of their applicability to so many. Well, how they handle so many different applications that are out there, whether they're prototypes, whether it's a production aid, end use part. There's just a lot of things you can do with it, and they finish up very well.
Dave, how does the speed of laser sintering compare to the SLA?
SLA?
Yeah.
Very similar. They both have basically kind of like an area that you can print within and create parts. I would say, as far as pumping out parts at a higher level, I would say that they're, for us, because you can stack them on top of each other because it's a powder bed, it tends to be pretty fast. I'd say around the same, but I would lean more towards SLS if I was going fast. It just depends. Some organizations might argue with that. It's just how we handle it. But they're similar. It's one of the methods that we have that we can pump out parts. Those two technologies, along with HP's multi-jet fusion, that system can pump out parts as well, because it's also a powder bed sort of situation. So, but instead of using lasers, this one is basically putting printing technology. It's 3D with HP, right? So they put down this little binder sort of situation where the part will be. Okay, so they lay that down. That'll be like a solidifying sort of situation. And then around the edge of it, they go ahead and lay another material that kind of keeps it within tolerances. Was someone going to ask you a question? I saw like a hand going up.
What do you mean by fast?
Well, not tens of thousands fast.
It's a relative.
So it's kind of a relative term. It's in terms of
we had some models
printing.
built that were about 8 inches by 8 inches, and it took them 24 hours to build.
Okay, so that might have been, was it maybe in like the FDM process, kind of the hot glue gun?
Yeah, it's like a glue gun going back and forth.
A little slower. That is a slower printing technology. You could probably print an 8x8 in. I feel more comfortable to have my post-processing software up, and I was able to go ahead and input a part. But not 24 hours, more like if it's an 8x8 solid, like a block.
Well, there were some cutouts and some,
Okay,
it had.
maybe a third of that or less. It really just depends. A lot faster. FDM is one of the slower printing technologies, especially if, depending upon the equipment. So if you're running, for example, a $2,000 or $1,000 little MakerBot or one of those type machines is going to print pretty darn slow. A $25,000 Stratasys FDM printer or FFF, fused filament fabrication, whatever you want it, whatever acronym you want to use, is going to print, maybe 5 times faster. Then you have your $100,000 one that's going to crank it out even faster. So, but either way, in general, compared to like SLA or SLS, FDM is pretty slow in general. But that kind of goes along with 3D printing or additive manufacturing. They're using that. You're hearing that more additive manufacturing because they're trying to use it more for that, gearing it towards that for the future. That's where a lot of development's going. I lost my train of thought. But as we were talking about speed, just lost my train of thought. Sorry. Does anybody know what I was talking about right before that? You can tell it's like the day, and then my coffee is wearing off. I was going to make a point, but I just lost it. It'll probably come back to me.
So while you're thinking about that, the hand finishing, texture dyeing and painting, can you take, these parts, or not, if you wanted to make something that was pretty,
Yes.
okay. So let's just say like a vase, okay? Can you make it, nothing that I've seen out of 3D printing is pretty. It all looks really plastic.
Then you need more exposure to 3D printing. So there, it doesn't come out necessarily looking pretty.
Right.
What you can do though, is you can sand it, you bead blast it, paint it. You can make this optically clear. Because on the inside, it's clear, but it's just a matter of, doing a little work on the outside. So you can do that with the technology. We have, I don't have it here, but when we go to trade shows, I've got this bird feeder. It's all 3D printed. It's a combination of, it's mostly SLA technology, this technology, and it's got a whole middle section of it that has been finished and using some gloss basically to go ahead and make it optically clear. People are like, wait, that's 3D printed? And I go, yeah. Wow, it looks really good. I go, it takes a little work to get to that, and I know I'm doing kind of hand puppets here. I wish I actually had an example of a finished part, like a really nice finished part that was pretty per se. But
you can
do a lot.
Produce parts that can have other applications added to them, paint, stain, whatever.
Yeah, like for example, that
But you can't
Stratasys.
print something that just comes off the printer looking pretty.
Well, I think it's a matter of perspective. So, this was printed just off the printer. It's got a really smooth surface finish. That
It's like
castle,
ivory.
that castle was printed, and it just pretty much came off the printer. And the only work that was done on it is an area where there was where the support material was touching. They did a little wet sand to it. So this is pretty much as is coming off the printer. A lot of people think that's pretty.
I think it's amazing surface.
So,
Well, yeah.
but if you're talking
Technology of making
but if you're talking about red paint
Yeah.
and optically clear kind of plastic, that would take a little handwork. And we do have an expert finishing department that does everything from just a quick wet sand to, let's say you don't have a product yet, right? But you want to take some pictures to go ahead and kind of sell your idea and show people what it will look like, give them a visual representation, a realistic, visual representation. We can make that happen. Some work.
When you say
We can make it happen.
when you say optically clear,
Not like your eyeglass.
not like an eyeglass, not like a camera lens.
Right. It's not going to give you that kind of,
It's translucent.
Mhm.
It is not optically clear.
Yeah, like if you're doing light pipes. Like Disney has this YouTube video, you probably Disney light pipes, and you see this cool little video of all these little things that they're doing with basically, I think it was a PolyJet 3D printer with their translucent Vero clear material, and they basically sexied it all up and they made it really clear, and then they were putting, you know, different color lights through it and doing little cool things like that. Not that that's necessarily the application, but yeah, that's more along the lines of the, you know, fluid flow. And usually people don't need it optically clear for a fluid flow test. You can get the sense, you know, by looking into that. But
Oh, they do optically clear parts. They're truly not cheap. I'm here to tell you, they're really not cheap.
yeah, there's a little handwork that you put into it. There's some technologies though, I mean, yeah, another relative term, but yeah, it's not gonna, you know, put you out on the street, but yeah, it's not cheap to have the actual work done to it to make it.
Okay.
While I'm looking, just as an example of finishing, and I'm on the HP technology. This is an example, and if it comes apart, don't be alarmed. It's supposed to, but it's like two halves of a bike seat concept. And part of it, the gray one, is as is out of an HP 3D printer. Basically, they blew off the, you know, all the powder and just kind of cleaned it up a little bit and didn't do it like any sanding or anything like that. And that's like as is. It comes out gray, not a sexy color. So most HP parts you see are black. They get dyed black. But this was run through a process, for lack of a better term, it's a process called Post-Pro 3D. I'll call it an automated vapor smoother because that's essentially what it does. But there's more to it than just like if you had like a makeshift little vapor smoother and you're holding it up, you know, some acetone. There's a little more consistency and reproducibility from part to part within a tolerance of half of a thou of an inch that you can go ahead and do. And this just gives you an example, and you can feel the surface texture of something that can be done in like 10 minutes. That's run through once. So, and it just gives you an idea of what it does is it also makes it air and water tight. So another part of finishing for an application, let's say someone needs something that's not going to be very water absorbent, you know, or, you know, air. You can go ahead and do that.
But you can get that part to have a mirror finish too.
Oh yeah, and then we can go to the point, we can either run it through the vapor smoother a couple more times to make it even look like more of an injection molded part, or we can take a next step and go at it with hand, which is a little bit more money because this is automated, right?
Right.
We can do it in like 10 minutes or so. So it's like, you know, $20 compared to, you know, 400 to really smooth it out and paint it with a Pantone color because we have a full paint booth and everything that we have. So we can kind of pretty much, and if it's a color that's available, we can get the paint and make it, you know, and apply it to your part. So, but that's just one example. We have a wide variety of sort of techniques we can use. I'll be providing a PDF to Roger, but if anybody wants paper copies, there's some paper copies of some of our finishing that we do per technology. It kind of breaks it down on what we'll do and the levels that we'll go. We have various levels that we'll take it to. But that's a nylon 12. Nylon, you're going to hear nylon 12 a lot. It's with the SLS technology that I was, oops, that's me doing that next end thing. Oh, yep, okay. Knew that wasn't in my slide. But between the laser sintered technology, you know, this one is something that the Post-Pro 3D can be used on to kind of smooth out so it doesn't have that bony feel. It'll feel more like that part that we're
But if
passing
that's
around.
a hidden part, why would you finish it?
If what?
If that's a hidden part, and it looks like a hidden part.
Oh, that's the thing. You don't necessarily, I mean, it just depends if that's a requirement. If you want.
I mean, if I was showing it as a prototype to the CEO, yeah, I'd finish it out.
Right. In a lot of cases, you don't have to. A lot of applications, most of our applications do not require any finishing, other than like, hey, like the SLA part, hey, let's go ahead and sand off this little area right there, little wet sand really quick where the support material was. That's the bulk of what we're doing. But sometimes people want it to go to the next level.
Sure. So you
Sometimes you don't
actually built the threads at the same time.
Mm-hmm.
Yep, that's pretty good.
Threads are all printed. And that's one of the benefits of the SLA technology with its, you know, this high fidelity. You know, you can really get some fine feature detail out of that. Also, same thing with the PolyJet. I don't have any really good fine feature detail examples of PolyJet, but But really, most of the time, we're printing an SLA unless someone wants color without any finishing, because PolyJet can do that, because it's printing in multiple materials at the same time. And I'll touch on that a little bit. But usually it's rubber over molds. Sometimes people will 3D print in a material out of the PolyJet technology, the Stratasys PolyJet technology, kind of their competitive product to SLA, 3D Systems SLA.
Is that where you have that like a live hinge, where you have the soft part interrolled with the hard part? Okay.
Mm-hmm. Yeah, they have various rubber-like materials that can be printed, because since they print multiple materials at the same time, you can print the rubber-like material right on the part instead of having, you could assemble it later. You could print them separately and assemble it later, but sometimes geometry just warrants itself. Yeah, it might have a fruity smell. The rubber sometimes has a fruity smell.
A what smell?
A fruity smell. I remember when I sold Stratasys, I'd have some PolyJet parts in my thing. I'd open it up and everybody would be like, ooh, who's got the air freshener? So it's just, there's some outgassing, that was in there, of course, but it smelled good.
So this is
It's okay.
PolyJet.
That's Stratasys PolyJet technology, right there.
How does that compare cost-wise to this?
More
jet
expensive.
fusion? Okay.
It's one of the
It
most
saves
expensive
assembly,
technologies that we
I
have
guess.
3D printed. It's, you're looking at, as far as material, they go by gram with that technology. As it's originally developed in Israel, Stratasys and then merged. And then you have Stratasys at the end, and Stratasys PolyJet under one umbrella. Although Objet, oddly enough, bought Stratasys and kept their name. And, which is, it worked out. I thought it was going to be vice versa, but it didn't. It was interesting to watch it happen. Yeah, so that's about 30 cents a gram. That's Vero White, which is about 30 cents a gram of material. I don't know how many grams that would be right there. It's not necessarily meant to be a strong part.
It is pretty strong.
So comparatively, you know what I mean?
Yeah.
Like the
It's fairly
FDM part
thin.
there, I can bounce the FDM part. That, if I threw it at the ground, I'd probably expect some splinter. Okay? Just because it's inherently more meant for precision, not necessarily performance. But there's some crossover, between those two technologies.
That bike seat, if that fell on the ground, would that splinter or?
Probably not. It's a nylon 12.
Yeah, it's not gonna go anywhere.
And that tech.
You can scrape it.
Yeah, you can damage it,
You
and
can
I
damage
appreciate it if no one, if you want to test something, I can get you, get hold me, I'll get you a little strip that you can test, because I gotta show these are communication pieces. I don't want them to be all marred up.
But that piece right there, you can do like a gloss finish on,
Jet fusion stuff, but
like
it's
that?
not nylon.
Mhm.
But yeah, is it giving off a little, I haven't smelled it, I'm just used to it now, I don't know if it does, but that's just an example of PolyJet. I'm kind of bouncing around, I know I'm standing on multi-jet fusion and we're talking PolyJet, but I feel it's better off to keep it interactive, and then, I'll dig a little deeper when I get to that actual technology. Because we've been talking about resin photo curing for a while. We were talking about SLA, we've been talking about SLA for a while, and that's our facility. That's where I'm at. That's part of our facility. And, rigid, flexible, translucent, all sorts of materials coming out of the SLA. And this is your original. When people sometimes they don't say 3D printing, say, hey, I need an SLA, kind of like Xerox, because they were like the original ones that came out with stereolithography. So that's kind of one of the, their hallmarks. Stratasys FDM, fused deposition modeling, hot glue gun, came out in '89. This is the one that came out afterwards. Scott Crump, anybody follows that. But then you have carbon. We haven't talked about carbon. Okay, so we've touched on it a little bit, but.
I'm Carbon X1 certified.
Oh, okay. Nice.
Yeah.
We have a couple X2s
Okay.
and an X1. I think those are the three that we have in our headquarters. We don't have any carbon at my facility yet. I think we're getting some more SLA. I think we're getting an HP printer, the new HP printer out at our facility soon. They're growing out our facility. We have 13 machines now between the Stratasys and the 3D Systems technology. But I don't think we're going to end up getting this. I think they're also going to keep housing the SLS, the laser sintering, just because it makes sense facility-wise in our Madison. I'll call it Madison, Wisconsin, because no one, like I said, knows where Blue Mounds is. But yeah, those are our three systems.
And those are liquid, and there's a laser that hits the surface of the liquid, And so it builds from the bottom and rises out of the liquid. That's how that works.
Yeah, so they try to, I keep over my coffee, they were trying to come up with a clip as like a, hey, something new. Really, it's digital light processing, right? So, and like you were saying, some people may have seen the video where they have this lattice work, geometry coming out really fast. And oh, look how fast it's printing. Well, that geometry is specifically designed to be printing fast and come out that quick. It doesn't usually print that fast. But really, so you got pulses, for simplicity, you got a vat, resin, you got light pulses coming out from underneath, and the part is slowly, as light pulses come out, it's slowly pulling out, the resin and built that way. So instead of a lot of them are built with something coming from the top and the tray dropping down layer upon layer, this one's the opposite. It's pulling up like that. So it's hanging, from the build tray instead of sitting on it. And it's very interesting technology. It's actually one of these that I'm least familiar with, but from more of a competitive perspective, and I've been learning more and more about it, as I've been with the organization the last 7 months. But this is an example of kind of like their ABS simulated material. If you're familiar with carbon, you've probably seen it.
Yep.
That's a topology optimization
Right.
example. So you're gonna look at it and say, that's kind of funky. So that's just, they optimized that with some software and then they 3D printed it.
And the idea of optimizing your build is the more you optimize it, the lighter it gets.
While still maintaining the strength and functionality that you require from it.
Yep. And that's not fully optimized.
Probably a.
That's it.
Go ahead. Yeah, feel free. And that's kind of like their ABS simulated. They've got other ones. This is a fun one, right?
Ooh.
Now this material, right?
Yep.
Yeah, you got a little scent. I'm gonna get it. Yeah, a little bit. Sorry. It's the nature of that material.
Right.
Not getting that out of this.
No.
I think it smells more like rubber. So this is polyurethane. These are all carbon's polyurethane. It's weird. Their company's called Carbon, and I get people say, "Oh, yeah, printing carbon," right? But no, that's just the name. They're printing with polyurethane-based materials, and they do a mixture, and then you're going to get a variety of different materials. I think this is a Shore 60-ish or 68.
Yeah.
Now, I preface this. This is a very tear-resistant material, but that geometry is not meant to be tear-resistant. So when I say that, I immediately say as people don't try to tear it, because that will probably tear, because it's a lattice work kind of thing. It's meant to be more spongy.
But you can compress it. Okay.
And it'll keep coming back.
Yeah. It's there's a word for it. It's a persistent geometry.
And when I think tear resistant, I'm thinking shoe sole. Like if we have a shoe sole that we printed, I'd start tugging on that. But that, yeah.
That's perfect for a shoe sole.
Right. Now, some people say, well, PolyJet technology, not to jump around too much, but PolyJet technology, the one that we were kind of talking about, it's the 3-smell one, right? So you got the rubbers. Now, one of the things that stick out about that technology, I'll say this first. I think that rubber-like material that you got in your hand is a lot better than the one in PolyJet. But, okay, PolyJet can print in multiple materials at the same time. So they create various, like they can print, let's say they're printing in, this white rigid, Bureau white. They have a black, a blue, and a gray. All pretty much the same properties, except for the blue is a little softer. And this is called Agilis 30. So it's a short 30, short 38 material. What you can do is you can create, since they're printing multiple materials at the same time, as they're laying it, so what it is it's like a 3D print, it's like a 2D printer laying down, instead of ink, liquid photopolymer. Layer upon layer is thin as 14 microns, depending upon which system. Most systems are printing as thin as 16. They have one that prints at 14. Unnecessary, by the way, unless you're doing some real feature detail geometry. On a flat surface, you're not gonna tell the difference. You're better off just using their 28 micron thin, which is, still pretty sexy looking part when you get it out of there. But anyway, so it's layering it, it's printing it layer upon layer, and it's doing a combination of the rigid material and the rubber-like material at various degrees to get various shore strengths. So you don't have to just print in the shore 30. You say, oh, I want a harder, I don't want Shore 68, like that carbon part. It's not gonna work for me. I need like a 50. I want it to be more realistic to what I'm gonna feel and show the customer of what it's gonna be like. And so that's also an area where that PolyJet technology kind of shines. Yes.
How big could you do something like this?
Well, so in the carbon technology, I think they just came out with a bigger system that we don't have yet. But the M2, the largest part that we can print is going to be basically a 7.4 by 4.6 by 12.8. That's going to be your build chamber size.
Yeah, that's 12.8 is a vertical.
Yep,
and
XYZ.
4x6, 4x8 basically.
Yeah, so it's 7 by 4, 4 by 6, and then
Yeah.
your 12 and change. So that's now they have a larger one. I think, is it called the M3?
Yeah, the M3.
And I don't know off the top of my head what the build chamber size is, but we haven't decided whether or not we're going to bring that puppy in. We probably will. So we just re-upped with carbon because we were kind of, has everybody heard of Origin? They have a competing technology that is coming out, and we were kind of looking at that, but after evaluation, we felt carbon was still the one to go with at this point. So we're probably going to invest a little further, maybe add a couple more machines. And if we add a couple more machines, we're probably going to be the M3, just for the bigger chamber. Because that's one of the limitations. Sometimes I have people who want to print rubber parts in that material because they really like that material. But
You'd like to print
it's too big, so we have to then
You'd
default
like to print a seat to sit on.
Yeah. Because then we have to,
It would
because if it
never-
gets too big. Oh, I'm sorry, go ahead.
Well, the whole thing about it is, if you did something like that matrix, okay, the seat would never wear out. You'd never have I mean, you still have to cover it, of course, but basically it would stay the same, I don't know, 10 years, 15 years. And seats in construction machines, if they last 2 years, you've got a lot of use out of it. But they really go fast.
And then that's one of the limitations, well, since with our M1s and our M2s, the two kinds of printers that smaller printers that they have, but sometimes it was, sometimes we wanted larger parts than could fit in those build chambers. And then I had one recently where someone wanted, the EP40 is what it's called, although it's a Shore 68. They wanted it in that material, but we couldn't do it. So we had to either say, hey, well, we do have much larger build chamber in the PolyJet technology. We can do that same Shore strength that, you're looking for, but and accommodate your larger geometry. It's not going to perform as well. So then we kind of work with them to see, okay, well, what exactly are you doing with it? What's the requirement, for this? And then
Ditto, Carbon's got a prototyping facility. They'll be happy to do it for you.
well, yeah,
And they have an M4 now too.
do that.
Yeah.
Yeah.
They don't advertise it. They don't show it, but they've got one.
The carbon, they don't really.
They're very
understanding
secretive.
They don't openly publicize.
Anything.
So.
I had to sign a non-disclosure agreement just to take the training.
Yeah. Yeah, so I'll give you an example. Within their upfront software, thank you. Within their upfront software, they have the ability to go ahead and create a bunch of different textures right on the parts, pre-made textures. And they call it beta just because.
Yeah.
Also, what they do is if a customer has a specific texture, they send to us in file format. We'll send it off to Carbon. They'll go ahead and then add it. They'll go ahead and create it for us and put it on the part.
Right.
So.
And of course, once they do that, assuming that the texture is
Just a few examples.
not proprietary,
They decide whether or not they'll add it to the library.
everybody gets them in the library, yeah.
If they
They have a
want.
beautiful library.
They're interesting to work with. What some people don't like, owners of the equipment, or people who are looking to purchase equipment, is the fact that they only lease it. You can't actually
Right.
own their equipment.
That's right.
You have to lease it.
And the reason they
That's
do
one of the
that,
reasons why we were thinking about it, but we did.
the reason they do it is because they are constantly, almost, well, at least once a week, and usually 2 or 3 times a week, at midnight, they upgrade the machine.
They're pushing updates, yeah.
They're just
Yeah,
pushing it.
they're very good quality control with their technology, and it's, you know, it's.
And they're very, very picky about their customers.
Yeah.
So you have to qualify as a customer before they'll even talk to you.
So this is the carbon?
Yeah, that's the
Yeah.
carbon technology. I believe that's their ABS-like material, their RPU 70.
And they
it's
have
just
lots of
multiple
different,
examples of textures.
plastics too.
This is kind of a fun one. Look at that one.
Now, the Stratus did
Different angles.
the Stratus did the one that, the longer piece that has the more, that's what that one did?
No, this one.
Exactly, that's the one it did.
This is the technology, and these are guys right here are printing either, they have some machines that will just print in one material, you know, at a time, I should say. Rigid white, blue, black, polypropylene type materials. Or they have the ones, you know, they discuss a little bit more openly, or you talk about, publicize more, like they have, like the Connex 3s. We have a Connex 3 that prints in 3 different materials at the same time. So you can, for example, combine a model, maybe an architectural piece that has white with, I don't know, maybe like translucent windows. I shouldn't have picked that example because you're not going to see much rubber on an architectural piece. But you have a third material that you can add, whether it be a color or, you know, something else, you know, to it at the same time. Or you can print a tray with those 3 different materials without them combining, you know, the parts. They call them mixed trays or mixed parts when they're referring to it. They also have systems that can print in 7 different model materials at the same time. So there you're getting to a point where you can really kind of dial in the properties of materials that you're, you know, looking to print. You know, you can do color rubbers, things like
You
that.
could build a car if you had a big enough chamber.
Well, you can print a car,
Yeah, right.
but whether or not you want to drive that car because of the material properties of those materials that they have is a fairly different question. Maybe, you know, maybe around the basement a little bit, your kid. Because, you know, but you could print a lot of different things. You know, they have, it's pretty interesting. Something that I think that they're really doing that's interesting is kind of the advances that they're doing with their focus in printing medical models. So they can, with a slicer like Cuttlefish, I mean, it's kind of getting into a software thing, but there's ways that you can go ahead and manipulate the material characteristics on because you know, like a pixel, okay, a voxel is a 3D pixel. Someone came up with voxel. And so you can manipulate at that level the material characteristics of each of those. You know, you can get to that point and you can really make like a hand feel really fleshy. It's disgusting. But I've had one in my hand, I'm like, oh, that kind of feels creepy, you know, like a cadaver, because that's the idea. So instead of waiting for someone who has a specific condition, spinal condition, or some sort of thing that you want to test or instruct, you know, doctors on or test on, you can recreate it to a degree with 3D printing. So for example, you know, this, you know, you can 3D print spine, it feels like bone, right? A fleshy hand. We have companies like
Surgeons use it to print the interior surface of a heart.
the Children's Hospital of Colorado.
Yep.
I think it's partnering with University of Colorado to some extent. And what they do for pre-surgical planning, Children's Hospital, and I printed one of these up for Children's Hospital as well when they were testing it, is like, I mean, like they were able to take that, you know, like that MRI, the CAT data, you know, and make it into a 3D model that you can then 3D print. And so then you can print a child's heart that has, you know, a deformity in it, and you can go in there and actually kind of, you know, go in there with a catheter or whatever, and so that you kind of do your pre-planning and your testing before you actually get in there, making it less of a practice of medicine and having a little bit more data before you get in there and go, oh, I didn't expect that. I didn't see that in the imagery. But instead, now you 3D print it and you can see it, you can plan a little bit better. It's kind of a good feel-good sort of application. And I like the, 3D systems, both 3D Systems and Stratasys have focused a lot in those areas. Spinal hardware, 3D printing metal spinal hardware, things like that. All sorts of cool things are being done.
It's better to have a polycarbonate spine than no spine at all.
Yep.
So, two questions. You mentioned a pixel and a voxel. So a vox is just a three-dimensional picture.
Yeah, think of it that way.
Okay, and then the software, as you're going from machine to machine, you basically can use the same model, and you're just telling it what materials to print where?
Now, it's not necessarily from technology to technology, because some companies like Stratasys are specifically focusing a lot of this, that sort of thing with the fleshy hand on their PolyJet technology, because they could print in 7 different materials. And they can make it a specific color and feel and things like that. They can really have element properties. Where you feed that same data to a laser sintering system that's printing in a nylon 12, yeah, you're not going to get all that. You're going to get nylon 12 because you can't dial in the material properties.
If you had the, what do you call it, the CAD file for that?
Yeah.
It's called a step file.
Yeah.
What?
Step.
STL, STEP, IGES,
Right.
any of those dumb solids, I'll call them.
Yeah, it's a solid
Step
model.
file. But you could take it and say, okay, print in that, print in that, print in that, and take it to different machines, that same file, pretty much.
Oh, yeah. Yeah, you can take that same file and print the part in multiple different technology materials.
Okay.
And you'd make your choice on what you want to print in based upon what you're trying to do with the part.
Okay,
Because
right.
some of them have, fine feature detail. Some of them
Right.
are a little more durable. They can take a shot. They're in, or you're putting it on an airplane, and you need it to be FSC certified. So you're thinking, different material. Old 10985, the Stratasys material for that. Let's see. Now, we already kind of talked about Stratasys, came out in '89, fused filament fabrication, FDM. Their term is FDM, fused deposition modeling. Now you start hearing FFF, fused filament fabrication, because people want, that's coined at Stratasys term, they coined that. That's their, just like, 3D Systems did SLA. So now people are just calling it laser, stereolithography instead of SLA. So we call it SL. I just call it stereolithography. I don't like to confuse people because everybody's used to hearing SLA. And that's why I still use FDM, even though a lot of people are using fused filament fabrication. But the reason why I bring that up and by the way, this is a hot glue gun. It's a little more than that. It's got a heated chamber to make sure the parts are within tolerance, stay within a certain tolerance, things like that. There's a lot more to it. But essentially, it's an extruder of model material and support material. And the support material keeps it within tolerances and keeps it, looking the way it's supposed to look. And they do that layer upon layer until they build up and finish the part. Now, same concept with this technology. This is an example of a technology that we are, in a very limited fashion, using for production for customers. The reason why very limited because we literally just installed it a couple months ago. And we're helping this company, newer company called Essentium, develop and bring their product to market, so to speak. We're kind of flushing out a lot of the details. Our owner did, our owner, powers that be, technical powers that be, did a lot of research on this technology and thought it was a really good fit and will be a pretty strong competitor to a company like Stratasys. Not that we're trying to build competitors that compete against Stratasys, because we have their products as well, but it's legitimate. And it prints, depending on the geometry, about 10 times faster. Everybody says that, about 10 times faster, but we tested it, depending upon the geometry, 8 to 10 times faster. But there's a lot of work still to be done with it. Right now, it's a single extruder. So if you need something that needs support material, we don't print this technology yet until it gets a little bit further down the road. One of the things that's going to be great about it is right now people complain, like, for example, With the Stratasys technology or any other FDM system out there, you know, it's not as strong in Z height. Like if you print this part layer upon layer up like that, it's going to be more, it's not going to be as strong in the Z height as it is in the XY. XY being like on a piece of paper, XY, right? This technology is going to have a process called flash fuse, and I'm not really dialed into the exact way it's going to work, but it's going to give it stronger in the Z height. So it's going to kind of minimize that. I guess make it perform more isotropic. That's a term that, I mean, some people will engineer it, you know, we have engineers here.
It means that that the isotropic means that the material performs the same in all three dimensions, X, Y, and Z.
Okay.
Horizontal and vertical is the same.
So although it's going to have a nice big build chamber, you know, it does actually. We have two of them at our facility in Blue Mounds, Wisconsin, that we're testing right now, and it's going to give some access to some interesting materials. Right now, we have a lot of materials available to us, including PEEK, but we're printing things to see, okay, what's it going to reproduce with that material? What can we reproduce with that material, you know, within a certain, you know, appropriate tolerance range that they're promising on a consistent basis. And once the technology gets to that point where, you know, it's, you know, we're helping them figure out how to do it. So,
Real value of that is you could print a container, a precision container, and you'd get it consistent every single time. That's really important, especially if you're talking about fuel that has to go into space. It's got to fit an exact size, it's got to carry an exact amount, and it can't change over time. That's pretty interesting.
it's going to do it fast. So it's a high-speed extrusion technology. So
And right now, they make those containers out of titanium, and it's all welded buildup. Well, the problem with that is that titanium costs about $250 a pound to put into space. It's not cheap.
So kind of to reiterate with the large build chamber, and you know, it's kind of going to solve some of the things that people wish were a little different about some of the, you know, extruding FDM, you know, whatever you want to call it, technologies that are out there as far as like the speed, you know, because FDM is comparatively inherently slow. And this is going to speed it up. It's going to be printed a lot faster, better Z strength, so it'll behave more isotropically, and then large build chamber size. You can get large build chambers now, you know, with commercial level equipment, but the price point at which you can do it with this technology is going to be a lot less if you're looking to purchase a machine. Otherwise, it's not a consideration. Right? That's our problem. It has a service bureau. So, but this is one kind of to keep your eye on. We're the exclusive provider of services for this technology in the United States for the foreseeable future.
Where are they from?
These guys are based out of, are they based out of Massachusetts? Seems like everybody is based out of Massachusetts or California. I'm trying to remember. I got it on a piece of paper. What I can do is I'll provide a little bit more information, because these guys are newer to us as well, a couple months new. So I'll provide some additional information on them for Roger as well.
Okay.
You know, if you guys are interested
That'd
in
be
sharing
great.
that with you. But this is one to kind of keep an eye on. That's why I thought I'd include it, because also another nice thing is this is where we're going to probably start printing metal. Unless we could decide next month to buy a metal print, but if we don't, this one is going to be able to go. They're already developing a couple of stainless steels, I think 4140 and 316L, a couple of them. So that would be interesting. Obviously, I think they're going to have a kit, you know, to put on, to swap out when you're going from plastic to metal. And we're going to have the introduction of a furnace and things like that. But, you know, we're waiting to see what happens with all that.
I'd like you to print an AG80 material, magnesium.
Oh, because of that,
Yeah,
because what you're working on?
yeah. Nobody does that yet,
No.
but that probably could do it.
Well, there's some, you know, keep an eye on the Mark Forges,
Yep,
you know, system and desktop metal. I'm not
talked to
saying that they're going to do it, but that would be where your entry point, if you were, I'm not selling equipment, by the way, but if you were looking to invest in that sort of technology, the entry point with those systems is, a lot less than the $1 million printer and infrastructure with your, DMLS systems, right?
Right.
Your direct metal laser sintering systems. But other than that, I mentioned urethane casting that we have a large dedicated urethane casting facility. So if with all of our 3D, with all of our additive manufacturing technologies, 3D printing technologies, and materials, if we can't get your requirements with that, that you need, your specific requirements for those, we can probably dial it in with urethane casting. Unless, of course, it requires metal. So we have a lot of capacity.
How does your thing compare to high density polyethylene?
I don't know. Honestly. Okay. Not sure.
You'll learn.
Yeah, that's one of the nice things, because I've been a Stratasys guy for years and desktop metal. Well, I shouldn't say desktop metal for years, but Stratasys since going back to 2001. And so I'm very, very familiar with their technologies. And what's nice is that I was familiar with all these other technologies, but for my, doing my own research, my own reading, their competitive perspective. And now being part of an organization that is actually utilizing all these on a daily basis, I become honestly more of a fan of SLA. More appreciation for what you can do with that technology, because I was positioning PolyJet technology compared to it all the time, but they're both good technologies, really good technologies, but they both have to fit for different things, So it's neat. And then, like you said, I'm just kind of like digging in and learning more. And, we have a lot of, it's hard to know the material characteristics of 45 plus different materials. So that's why I carry around these pieces of paper to tell me. I got little cheat sheets, and technical experts, if I don't have questions, answers to questions and things like that. So, but yeah, I've got a passion for this. So yeah, I'll learn a lot of that stuff. I did already talk about the Post-Pro 3D vapor smoothing, air and water tight. It makes parts air and water tight. It's not for every technology. It's for HP's multi-jet fusion. It's for, the laser sintering parts. It's for the fused deposition modeling, the Stratasys parts, things like that. That's where it's used. And it makes the parts air and water tight and can smooth them out so that they're more of an injection molded type surface. And it's controllable within about a half of a tenth of an inch. Some people say, depending upon the geometry, they'll say, a tenth, just to be safe. But then the nice thing about that is if you're pumping out a bunch of those, knowing that it's going to be it's going to change the surface finish, the tolerances within a certain tolerance, right? That's controllable, you can design for that. So then you're talking about designing for additive manufacturing, kind of like if you were designing for injection molding. Then you get into a whole different conversation where you just go ahead and modify your geometry for that process, because it's going to adjust by that tolerance. So then you can, that allows you to dial it in a little bit better. And then, of course, I mentioned, we have a pretty stringent quality management system. Recently, we added a Creaform. Everybody's ever heard of them? Creaform handheld metrology grade 3D scanner, handy scan. Well, it's pretty darn accurate, but then, of course, there's some scanners out there that I've seen at Medtronic and places like that can see inside of geometry. So it's not getting you there, but it's really great for some quality control applications. And obviously some product development. I hesitate to say the word reverse engineering, right? It tends like you're stealing someone's idea. Not that ever happens, but for production, product development, scanning and things like that. You have some old castings, and you just don't have the drawings, and you want to reproduce them, so you scan them, you bring them into your software, and then you go ahead and go from there. So we have a lot of different nice things that we can do. Tensile tester to independently verify, material strength, things like that. These are just some examples. I've got a full email with a bunch of links of all the different things we can do that we were required to do to be able to have the kind of aerospace certifications that we have. And some of that is like, the softwares that we invest in, right? So you got Materialise is a popular one that's out there that does various things that basically, if you send us a file, we'll bring in a new software called Magix that we can, we can let you know, hey, you got some errors here, and we're going to go ahead and fix these errors for you with your permission, or you can fix them and send it back to us. But we have the capability of doing that, because if it's not like a solid part, it has errors. Some of the stuff, you can't print it sometimes. You have to have like a watertight kind of part, so to speak.
Is any of your printing capability have conducive to electrically conductive tracing, so you could put like a printed circuit board embedded in your printing?
Well, so there's actually printers out there that print that nano dimension just for fun. We don't have it, but I used to sell it for like 3 months before I left my previous company. We just brought it on board, and they're 3D printing circuit boards and things like that. You can, I mean, are you asking, can you embed it while you're 3D printing it?
Yes, exactly. Let's say that I
You've got
wanted
a-
one of those parts, but I wanted to put some electrical circuitry into it, a little microchip. For
Well-
whatever reason, let's say it was that nylon one.
I don't know that you could do that during the actual printing process. There are situations like with FDM parts, like Stratasys, what they'll do is they have a software where you can go ahead and tell it up front that, hey, I want to pause the print job at this point, and I want to create a space where I'm going to go ahead and lay down like a washer or some sort of metal insert, and then restart the job to print around it and things like that. But as far as circuit, I hate to ever say no, but I don't think so. I don't think so. I mean, I know that I'm sure there's a way to get that stuff on a 3D printed part, but I'm not sure how. But I do know is for fun, nano dimension, if you're interested in that, look that up.
Okay.
It's very expensive. I'm not saying buy it, but there may be a service provider out there who's doing that and 3D printing, utilizing that equipment to 3D print. It's very niche right now. There's like 50 or so in the world of those printers, but it's a $250,000 machine, but it's very interesting. It's kind of fun. He's got all the good questions. No, I'm kidding. I don't mean to say that no one else has good questions, but he's got the ones I can't answer. And then, then we obviously, can take in various file types. Like you mentioned, like you can send a step file to, like, for example, you mentioned that file type. So STL is kind of like the default file that people send each other to load into a 3D printer. But these days, these companies are now making softwares that will take in like native files, like your, a SolidWorks part file, a TIA file, and then they'll bring it in right into the upfront software. But what we do is we have these softwares at our facility as well, so we can bring in all sorts of multiple type, file types that people might have. But most people can go ahead and generate a step, or an IGES file or an STL. Those are just like standard generic type, solid model type, files.
How much design work do you guys do? Is it just kind of like clean up, like I build the file, send it to you, and you do some cleanup work and print it?
Yeah,
Or
we don't actually do the design,
Okay.
but we have, you can imagine, we have people who come to us and say, hey, I've got an idea. And I'm trying to figure out something that I can go to market with. And I'm looking for a designer, or you guys do design services, because you do 3D printing. We don't, but we have partners who do, and we just point you in their direction. And then from there, then once you have the design and you figure all that out, then we can go ahead and have the prototyping and things like that.
Do people ever bring you a part that's made out of something else that they want made out of something?
It's funny that you say that. So then, like earlier, I was talking about how we brought in this 3D scanner. So they have a part, right? And they don't have the design for it. So they can't give us any CAD data to go ahead and 3D print it. So what we do is we'll be able to, since we just brought it in, we'll be able to scan it with this 3D scanner. So it's going to go ahead and create this mesh, so to speak, this physical representation that you can then bring into your CAD software. Or actually, with this, you can actually go, instead you can bypass the CAD software and you can go straight to 3D print if you want, depending on what you want to do with the information. So people have asked to do that. And before we've got to say, yeah, well, you're going to have to get that scan and then come to us with it, and then we can 3D print it. But now we're going to be able to do that ourselves.
Can you, so you guys do prototyping stuff, but you can also do production stuff. Like somebody could come into you with a part and say, can you 3D print me 10,000 of these?
Now, 10,000 is going to be pushing the envelope. Okay. depending upon the size of the part, right? If it's a little tiny doodad and we have a good sized build chamber, we can, do hundreds at a time. But really, when you start getting into tens of thousands, you start thinking traditional manufacturing, because at that scale, you can go ahead and, get a mold made, cut steel, right?
So then where is your sweet spot for manufacturing?
So for additive manufacturing, we're talking hundreds, thousands. Like us, people come to me and say, well, we have a certain quantity of what we're going to do. We want to 3D print this part. And, they're talking, 1,500, 2,000, 2,500. Okay. That's kind of pushing it a little bit with 3D printing, depending upon the geometry. It's a favorite thing we like to say, it's geometry dependent, right?
Can you ballpark a quote on?
I can't ballpark in my head.
No, I know.
Oh.
I mean, but if somebody brought a part to you.
Mm-hmm. Yeah, if we had the geometry, like, hey, here's the file, here's what we're looking to do with it, here's your material requirements. Okay, yeah, that could be 3D printed, or it can't, we'll tell you. And, or, if we did that, it would be the best application for it. And then we could go ahead and work up numbers, yeah. But then sometimes we decide, okay, urethane casting is a better idea. Because then you give a mold that, and then you can, depending upon what you're shooting in the mold, you can get a good quantity out. So, just depends. Sometimes when we're thinking end use part applications, we're either thinking the SLS technology. We're thinking, HP, multi-jet fusion, more durable type materials. Oddly enough, some people are doing end use part production in SLA just because of the specific application that they have. So they usually it's MJF, HP as the MJF, SLS, or we're thinking urethane casting.
What was the bicycle seat made of?
That was HP's MJF, nylon 12 simulated material. So very similar to the nylon 12 simulated material coming out of the powder bed for the EOS laser sintered system.
It all depends on the production rate too.
Yeah.
In other words, if you need 100,000 parts, but you need them over 10 years,
okay,
then this might be a good way to go.
Yeah.
But if you're going to do that, then you ought to buy your own machine to do it. Not get it from him. He's a nice guy, but if you're going to produce a part over a period of 10 years,
yeah,
he's not the right guy to talk to. You need to talk to a manufacturer of the machine.
You do the math, right? Yeah.
He's the guy that helps figure out.
So that's people sometimes that come
And
and
he'll
say,
tell
hey,
you.
we'll say, here's what the cost. We'll give you the quote. Here's
Right.
what it's going to cost you to print that over a period of time.
Right.
And then you do the math. Okay, here's what it's going to cost me to buy the printer
And
and
the
have
staff
someone
to
run
run
it for
it.
me, and then I buy the materials and maintain the machine and see what works out.
Yeah,
There's a certain point.
You
right.
can print like 2 or 4 at a time too, right?
Oh yeah,
And
depending
if they're not
upon
that
the
big.
geometry.
Yeah.
And in the powder bed ones, you can stack them. Like you can fill up the whole
Okay.
box, you know what I mean? The whole build chamber. So that lends itself to, pumping out various geometries, whatever you can fit in there, right? So that's why when we think end use parts, that's both those technologies I mentioned, excuse me, are both powder bed type technologies that have that kind of that powder cake, so to speak, that you can throw all those parts into and build. So
I totally can't visualize this powder thing.
I wonder if this is when you go, grab one of these, because it's kind of giving you like, there's your powder and there's the parts inside the powder. So
This is the one that's coming up.
No, that's the DLP, the one that's coming out with the thing here. That's that
My
different
head's
one.
spinning.
Right, yeah. So that's why this is kind of like, this kind of simplifies it a little bit
I'll take
visually, and then you can always, hey, Dave, I got your card, I met you, and can you send me something that might communicate this a little better for me? And I send you a little video that says, hey, watch this. Because it's seeing it's a whole different thing. Oh, I get it, because then the parts are surrounded by all the powder and they're inside the powder, and it's kind of like building it layer upon layer, right? with a laser, and then it's just,
But whatever you don't use, that powder can be reused.
in most cases, depending upon the technology.
Yeah,
So
pretty
you're
much.
not having the, what do you call it,
Sometimes
the
there's waste.
filament that's on the roll, the long string of
Oh, the filament?
plastic?
Yeah, if you use deposition modeling, that's usually a filament with a weed whacker. Right, a weed whacker material.
Yeah.
Is technology kind of going beyond that now?
Oh, the
Way.
weed whacker material?
Yeah, I mean, I saw that a lot at CES, and there's like 100 different manufacturers.
Right.
Small little-
Yeah, because Stratus's patent ran out. Everybody says,
Yeah.
hey, me too. And let's do it at $1,500 or $500, or hey, make your own. So it's cool for tinkering around, and you can actually do some simple, jigs and fixtures and things like that.
It's definitely
So, but yeah, and sometimes they break, you don't have time for that if you're, depends upon your situation, but.
If you want to just mess with a little jig or something, you can go to maker spaces.
Exactly.
Yeah. and
That's
they-
where I would go.
Yeah. And they often, sometimes you get one of those kids that's in college or like a senior in high school, and they're just geniuses, and they'll sit down and help you do your file too. So, at those places.
That's a great place for them.
Mhm.
That's a great place for that technology. Juices flowing.
Yeah.
I hired a ninth grader to do an app for me on my iPhone.
Really?
Yeah, a ninth grader.
Yeah.
Yeah.
Look at an intern, he's a junior in high school, I work for
From
Democratic
Indeed?
schools. Look at an intern. This guy is, I mean, he operates at a level that you think he's probably got like 15 years of engineering experience.
Sure,
He's a junior in high school,
sure.
yeah.
Yeah,
So he's
this guy was
blowing
a
the rest of
freshman.
us just people
And-
out of the water.
There is no such thing with handheld technologies. There's no such thing as a 30-year experienced person. That doesn't exist.
Right.
What you want is somebody who builds their own app or apps, and it doesn't matter how old they are.
Right.
Absolutely doesn't matter. What you're looking for is performance.
Yeah, feel free. And, if you guys don't want to sit, and you want to take a look at the parts a little closer, I know I passed some of them around, feel free. That's what they're there for. I mean, there's some that I haven't even shown anybody. This is a EMI shielded urethane cast part. So this is an example of something that comes out of urethane casting.
So what does that mean, urethane casting?
So the traditional process, I guess call it soft tool. Excuse me. Residual from my 2 week ago flu that everybody's been getting and has that cough. Sorry, not contagious, hopefully. Just kidding. But urethane casting, soft tooling. So then basically you'll print, let's say you have a part, let's say you want to produce a bunch of these, right? Or, this might be bad geometry as an example, but just, a part, some of this, or these doodads, right? A bunch of these, you want to do a bunch of these. So we'll go ahead and 3D print this part in a really high fidelity, smooth surface material. We typically choose SLA Accurate 25 as that material. It just seems to work very well for master patterns. And then, so we'll print that, and then what we'll do is basically we'll go ahead and, you got like, picture this wooden box as an example. And in there, basically, you've got the part, and we're going ahead and doing like a silicone. So you're basically putting silicone in there and, creating kind of like the two negatives. Okay. And then I forget who asked, but I'm looking at you. Okay. And then basically after that, what you'll do is then you've got your mold. Okay. And then what you can do is you can inject in there like polyurethanes to go ahead, combination of polyurethanes, whether it be to create a rubber-like material or, whatever you're trying to do. There's so many different out there that you can kind of dial in.
What this fella here is holding, I'm sorry, Dennis? James. What James is holding is a joystick.
Yeah.
Cobra
grip.
A joystick grip. And
Flight simulator.
yeah. But the beauty of that, what he's really talking about is the ability to mold to a specific hand. And that's what the pilots are doing these days. They get one of those and it's molded specifically for their hand. So that, and they just pop it off the joystick and they carry it with them in their bag. And when they get onto the airplane, they pop it onto the joystick and now they've got something that's molded to their hand. If you're going to hold on to one of those things for 6 or 7 hours, it had better fit you.
Where does the break even come on urethane casting then?
Compared to,
Hmm?
break even is like,
Well,
compared to like doing it via 3D
say the
printing.
energy,
We'd have to do the math. Depends on the jet. Again, you're geometry dependent. It depends on the situation, but, so what you would do is like you would say, hey, you know, by the way, my cards and all that stuff is over there. I've got cards in my pocket in case anybody's interested in that. Plus, I'm sure Roger's gonna share my information, but if you would contact me or someone else, Service Bureau, and say, hey, urethane casting, what's it gonna cost? This is what this needs to do, this is the material that, you know, this is what it needs to do. Compared to, you know, then we'll say,
Lot
hey,
of,
do you have any other
explosions
you know, added
and stuff in
manufacturing
this area.
technologies?
That's
What else
the
is
problem.
same thing, and then we can give you price comparison, and then you can figure that out. So it's.
it's typically a higher volume than that, right? It's not typically done for 10 parts, say, or 20 parts.
Sometimes it is, if your material characteristics that you need or performance you need is only going to be achieved with urethane casting tools. And we can't quite get there with 3D printers. So in that case, yeah, because that means, okay, you gotta get it.